Hello everyone. Today we are going to discuss why insulation matters and how it works. So in the US, it is expected that around 16 million households are unable to pay for the energy demands of their household. This means that they are energy insecure. In a lesser definition, this means that if you spend more than 10% of your gross income on your energy needs, you are considered energy insecure. Around 51% of households making less than $25,000 a year, in order to pay for their energy bills, have to cut back on necessities such as food and medicine, and this primarily affects low-income and minority neighborhoods. Although this can be easily changed by improving insulation and window efficiency. So around 30% of energy used in commercial buildings is wasted. So if you want to save money, you would want to increase your window efficiency as well as your insulation, because it saves you more money. On a more personal level, 1.4 million households reported that they needed medical attention because their houses were kept at unsafe temperatures. So improving insulation and window efficiency also helps to save people's lives. But also what's not mentioned is that it also helps to save the environment, because less energy is used, there's less demand on the grid, so more energy is saved for a later date and not used currently. This overall means that insulation makes the world a better place with very little cost up front, and it saves considerably more money in the long run. This can be shown here with a very simple example of windows with a double pane versus single pane. So the reason why your double panes are considerably better is because not only do you have twice the conductive resistance that a single layer does, but it also adds a convective resistance with the air pocket that is trapped in the middle, helping to further insulate the window. A much greater example can be seen here. That's the scale of a wall with two steel plates and insulation and support beams within the middle. This is represented as a thermal network in the bottom left image with the resistors. The top right image shows the temperature across the wall. So as it can be seen in state 1, the temperature is at its highest inside of the building. At state 2, the temperature stays relatively the same, as steel is very thermally conductive, so it stays relatively the same. The insulation, though, provides most of your thermal resistance. As such, you can see the major drop in it. And then at state 4, which is the outside, it's pretty close to the outside temperature. The bottom here shows the heat transfer rate with different scenarios in the wall. So the first one in the blue is the standard one, and it's the one that you see before you with the fiberglass insulation and the steel plates. The second one that you can see there is if you completely eliminate the inner steel plates while remaining with the exterior ones. This considerably drops the heat transfer rate to around 92, comparing it to around 400 of the last one, with a very exponential, or a heavy exponential drop in it. And this is a very positive increase. The next two are fairly constant changes, but they do add more to the overall cost of the build if you were to make it. So the first one is a plaster interior wall. So this does help a little bit, as it lowers the heat transfer rate about 10 to 15 watts. And this is because it just adds a simple layer of material that it further stops heat from transferring through. Similarly to a cement wall on the exterior, it just slows it down a little bit, but it's overall fairly constant to the original one. The next one is one of the more interesting ones, as it shows a more linear rate to the drop in the heat transfer rate. So in the second one, the insulation is doubled from 20 centimeters to 40 centimeters, as well as the steel plates. So nothing else has changed, but the thickness of the wall has almost doubled. But this gave just about twice the thermal resistance, and as such half the heat transfer rate of the original one, showing a dramatic increase. Not quite as much as completely eliminating the inner steel bars, but fairly good. The last one in green shows that if you were to replace the fiberglass insulation with plastic bags. So this shows a dramatic increase in the heat transfer rate because plastic bags are not nearly as good as fiberglass insulation is, but it offers a much cheaper alternative to the fiberglass insulation. And although it is a negative outcome, as in that it is less than the standard, it still shows that something can be done if you were to use plastic bags, which there are thousands, if not millions, of plastic bags that are just in trash and can be easily converted into something useful. And that is all that I have for you today. Thank you for listening.